Yeah, let me do it again. So text, let's use text. So zero coupon bond price is P equals F E to the power of minus RT. Okay, so it is Google Colab. So it is work fine with Chrome browser, which is again made by Google. Okay, this is, yeah. So, right? So it is zero coupon bond price. So we'll make it, right? So the price of zero coupon bond is like this. Bond given face value F is, yeah, face value F. It looks like this one, right? And then given this zero coupon bond price, of course, we can recover the yield to maturity, right? So here, so from this, we can find the yield to maturity as what? So we want to solve by solving for R, right? As then how to do it? Of course, we can take log each side and move around. Then what we have is that R, what we have is R equals, because it is the ratio of the price, so log we have a log, and then log between F and P. Okay. So you can see this side. So the ratio between face value and current bond price is overall return over the whole period. So 0t. And then we want to normalize this one with time. So this is basically same to this one, right? So both of them contains exactly same information, right? More generally, yes, so same to this one. This is straightforward. Actually, we can find more general one, annualized distance. So if we have two, when you have two prices over time, you can compute annualized return as so suppose you are interested in finding annualized return from T to okay. Oh, where are they? Oops. They all disappeared. Where are they? What? Come on. Come on. Ah, okay. Okay. I'm not sure whether this is memory problem, but right. We are interested in finding annualized from T to T plus delta. We are interested in this one. And of course, this one we can calculate as this one is simply first in general. Okay. The same spirit, we calculate log ratio between P T plus delta over P T. Let's use this bracket. No, this bracket. Right? So basically, to log price ratio between two is the return between them. But this is not annualized return, right? So the log ratio between the two is basically return, but they are not annualized yet. So in order to annualize it, we divide it with the time between the two, right? So 1 over, right? We can do that. So basically then we can calculate annualized return as follows, okay? And of course, given the property of the log, we can, this is often approximated with, not exactly the same, but in terms of discrete rate, it is the 1 over delta. And then this is sometimes written as P T plus delta over P T, and then minus 1. Okay, right? So this part, this second part is more familiar to you, right? So this PT plus delta over PT is like a gross return. If you subtract minus 1, it is a net return. But it is not annualized. So to annualize it, you have to divide with time between the two, right? You are familiar with that. Now, let's use the data in our textbook. So, wow, this is the huge logistics problem. Okay, let me try. So in our class website, you can access our class material over here, right? So this one, we have like class PPT slide over here. And then let's check this one, class introduction. Okay, class introduction. And then, yeah, we have this data. So let's use this data for some practice. So first, let me first import numpy smp. NumPy is the package, popular Python package. So inside NumPy, we have log and log exponential function and like that. Okay. So and then from NumPy, import log and exp. Now we can use log function and exponential function. Okay. And then we have in the data, we have 3 bonds, right? 3 bonds. So let me copy these 3. I hope it works. Okay, it works. So what? They are the bond price. So bond 1 price equal 99.1778. Students, just don't watch. Please use your own computer and follow me. And then bond 2 price is this one. And bond 3 price on the bar price is 9x point this one. So basically, I'm using this data. Okay, that's good. And then we need a face value. face value, and then actually maturity. Okay, first maturity. So this is maturity. And so let me this one. So maturity. So bond one maturity equals this one, and bond two maturity is this one. Bond three maturity is this one. Bond three maturity. Okay, maturity is this one. And then face value. And then above face value, right? And then bond one face is of course 100. It is always normalized 100. Bond two face value is also 100. Bond three face value is also 100. Okay. Wow, it is already over 50 minutes. 50 minutes is simply too short for the class, right? And yeah, let's continue. Okay. We have face value. Now here, okay, yield, of course, yield is from price, right? We use previous formula, so okay. Bond one yield YTM, yield to maturity, is bond one yield to maturity is what? Bond one yield to maturity is log. We already learned how to do it, right? What we learned is that bond one face over bond one price. And then we have return and we have to normalize it. Normalize it. So basically we are using this formula, right? Yield to maturity. Divide one is bond one maturity. Maturity, right? And then copy paste. And then bond two YTM is bond two, bond two, bond two, and bond three, three, bond three, right? And let me check. Print bond 2 item, bond 3 item. Let's print. Yeah, there is yeah. So we can compare this value and this one. They are not exactly the same because of rounding error. But this
Professor,
is
you forgot to change number 18, bond 1, 2, bond 3.
right. Thank you very much. This one, right? Yes. Let me 17, 21, 26. 17, 21, 26. Okay, and fine. Okay. And then in the table, we also have a forward rate. Now, forward rate is, of course, about forward rate. The forward rate is to compute the forward rate. This is the, well, forward rate is here. What you can use is you can use kind of intuition. Intuition such that let's write, actually, let me write down over here. Okay, so let me tell the text. So intuitively, what we can do is for intuition about forward rate. Intuition about forward rate is, let me save. Intuition about forward rate. Intuition about forward rate is that suppose we have return it doesn't matter whether it is a short return or long return or forward rate. Return from 0 to right arrow big T. Let me say big T. And then, okay. So if we do this, it is the return from 0 to T multiply big T. So it is return overall return from 0 to T because R0 big T is annualized return and then multiply annualized return with time, then you have gross return. So intuitively, we can decompose this one into R0 right arrow alpha T1 alpha. Let's use alpha. And then, okay, of course it doesn't, what? I forgot R underbar over here. Okay, this one. And then from alpha to beta. And then from, now it is kind of forward, right? Because it is interested in the future from alpha right arrow big T. And then, oops. And then it's a T minus alpha. This is intuitive, right? So the gross return over big T period, this R is small 0 to big T, is can be decomposed into small return from 0 to alpha. Gross return over alpha period and from alpha to T and the second part. And this should hold. So for forward return, because the second part is the forward return, so we can calculate second part. So how to calculate this one? So we are interested in computing this one, right? We are interested in computing this one. Future return is of course, this part minus second part okay, second part. But then, of course, we have to divide each side with t minus alpha, right? So t over divided by t minus alpha. This one divided by alpha divided by yeah, okay. So right. So this first equation is intuitive. Long run return, we can decompose the series of the gross return. And then we are interested in forward rate for the future time from alpha to big T. We are second part. So we know to calculate second part, we can just move around and divide each side with the future period. Okay. So we use this one. So how can I do it? Forward rate. Forward rate is simply you can implement that one, which is there any other better way? Okay, that's one method. This is one method. Okay, and then actually another method is we can simply use this formula. This formula. So let's say what is the notation? Forward. Okay, let's bond one forward. What I'm here is I'm trying to use the easier way forward. This is 2 FWD. Okay, this FWD, FWD. Okay, and then even forward rate, it is again same. It is the ratio between the two prices. Okay, so what we can do is bond one maturity. Okay, and the second one is bond two. What we can do is bond one price, bond two price, and then bond. We need a difference between the two. So bond two maturity minus bond one maturity. And then we have a bond two price, and then bond three price, and the bond three maturity minus bond two maturity. Okay, let me save. And then let's print. And then here, let me distinguish between one. Okay, and then forward. Okay, so 17, this one should be same to this. So 17, 25, 252, 358. 252, 9, but it is round error, so it is fine. So we have forward rate. So there is two way. You can calculate forward rate this way, or you can calculate forward rate such as what I use. My method is this one. Forward rate is R. Forward rate from T1, forward rate from T to so what I use is forward rate from T to delta. T and delta is for the future period. So what I do is basically 1 over delta, 1 over delta, and then the ratio of the two price. Mean ratio of bonds, what notation? P, I know the notation P, right? P 0 to T divided P 0 to T plus delta. Sorry, I have a two bracket. Delete one bracket, and to make it pretty, let's put dot over here, C dot, comma dot over here. Then yes, so actually I use second one. So forward rate between the two future period, it is exactly the same. The intuition for this forward rate is exactly same to the intuition of this one, right? So the rate is basically the annualized rate is between ratio between the two prices, actually log ratio between the two prices, divided by passage of time between the two periods. So I'm interested in forward rate between the two periods, then I can calculate price between the two bonds, right? Price between the two bonds, and then get the log ratio of it, and then annualize it by dividing with the time. And then my formula is exactly like this. Actually, in order to make your life easier, bond class practice today is the date is the to make your life easier. I will share this one. Share anyone on the okay, anyone can access it. Copy, and then where is our class web page? Whoops, I closed it. So teaching list. Let's go teaching list. Okay. Now this is for today, and then fixed income securities. Fixed income securities. And then today, okay, to make your life easier, I'll connect this one over here. Oh, what? Come on. Okay. Okay. Now you can access this Python code over here. Okay. So actually we did that, but thing is that this whole code is instances to right? This code is highly inefficient. Actually, we can make this code more efficient by using object-oriented programming, by using Python class. Okay, so let's do Python class. Let's make this code easier. And then let's add code. So what we can do is, I think, more smart way is make a class, okay? Class and make a bond, okay? For the time being, it's, let me say, it is pass. And we have 3 bond, right? We have 3 bond. And then so bond 1 equals bond assign memory in the class. So they are called instances. So bond 2 assign memory in the class. Bond 3 assign memory in the class, right? What? Bond is not defined. Right. Class bond. Yeah, now, yeah. Okay, assign memory and let's make the code more efficient. And then in order to make it more efficient, what we can do is here, define method init. Okay. And then self, I have to do already instance. And then we have phase maturity, and then price, right? We have this 3 things. And then we need this one, okay? And then self to save the name, self face equal face, self maturity is maturity, and self price, self dot price equal price, right? And the self YTM, of course, we also have YTM, but for YTM, yield to maturity, we can calculate yield to maturity from the other one, right? So basically, it is log of yield to maturity, log of face log between face value and then price and annualized it with maturity. All right. So let's see. So now bond one is face value is 100, and then maturity is 0.5, and price is I have to let me copy this one. Let me copy this one over here. Okay, just for the information. Okay, so this one, and the bond two. Again, it is a face, maturity, and price. Face value is always 100. Let's make it floating number. So put that. And then this is 1 year. And then price is this one. And then 100, 1.5 year. And then this one, right? And then let's see. Now I don't need to this one. So, and then print bond one, YTM, bond two, three. Okay. Okay, now I have a exact number. So it's to briefly explain what is going on. So bond one is I assign memory in the class, so bond 100. So first argument self. So self is this one self, bond one. So equal this one. And then next face value is 100, maturity 0.5, price 1. And then I want bond 1 the maturity, but self, here the self is this one, bond. So this inputs bond 1, this one. So self yield to maturity, calculate this one. So it does this one and they print out this one. So now we have much more clean code by using class, all right? This one is much better, isn't it? Uh, any question until now? Any question? Okay, let me do another practice and then define. Now define bond pricing for the bond value. Bond value. Define bond value. And then of course I have to call self first because call instance. And then to bond value I need F. And then I have T and YTM. And then what we have to do is return F face value multiplied by exp minus R minus R multiplied by YTM, right? Then we have a bond value. So let's test it, whether it works or not. Okay, so so here print bond print. Let me and then print bond value, right? I want to calculate bond value of what? Bond ones, bond ones, bond value, bond ones, bond value, in which the argument is the I need bond one face value, bond one, and then second one is maturity. Third one is bond one, which we know YTM, and then we print it out. Oh, 이런. Oh, sorry. It is not R. YTM multiplied by T. And then if we calculate it, And then the first bond price is 99,1338, which is exactly same to print bond one price, right? So they are almost same. This input variable. So from input variable, I using our YTM, I reconstruct the bond price again, and we have a consistent value. And then we can check others as well. And then change everything to 2, 2, 2, 2, 2, and then 3, 3, 3, 3, and then if we run it, then right, besides the first one, we have exactly 7. This looks ugly, so instead this one, let me round 4. Okay, then we have exactly the same one. Okay. Any question up to this point? So again, we briefly we learned how to. I mean, look, this one is very ugly, right? This code is simply too long. Oops, this code is simply too long. And then if we use this class, then everything is so straightforward and clean, right? So this looks much better. Yes, I think that this is enough for today. Any questions so far, student?
Professor,
Yes.
I think I have to learn some codes of Python. So can you tell me some website or any website to get these informations?
Information to learn Python?
Yeah, I mean, at least the codes which you used today.
Well, there are 2 ways. Just follow my class carefully and review what you learned today. Okay, I think that's maybe the best way. Another way, if you are really serious about learning Python and want to be more proactive, and you can simply visit the bookstore and then buy a book which looks easiest to you. Okay, some students who are over ambitious, they buy unnecessarily difficult book and get stuck with it. That's not a good way to learn programming. The better way to learn programming is to start from very easy one so that even middle school student can follow. And then once you know basics of Python, then you can look at other people's code and learn from it. That's the easiest way, quickest way. By the way, there are also a lot of websites about Python. And then even in YouTube, actually YouTube is very good. In YouTube, you can find very good materials for Python introduction. Okay, so yes, to summarize, just buy an easy book or Google it or search YouTube to find material to learn Python. Any other question?
Professor, I have another question. You mentioned about the bonds annualized return for YTM. Should we use a geometric mean or arithmetic mean while calculating YTM?
Calculate YTM. What does it mean by geometric mean? And then, you know, in finance, everything is geometric mean. When we say mean, it is usually geometric mean, not arithmetic mean. But of course, since we are using continuous time exponential function, and if we take a log return, And then that arithmetic mean of that log return is of course same to geometric mean. So that's why we love log and exponential. Because in that case, we don't have to distinguish arithmetic and geometric mean. In terms of log, they are same. So in the class, in the Python code we learned, basically you are using geometric mean, but it looks like arithmetic mean because we are using log function.
네, 알겠습니다.
Yeah. If you have hard time in understanding English, or if you feel uncomfortable speaking in English, you can ask in Korean. You can ask a question in Korean, and then sometimes I can answer your question in Korean. 한글로 물어봐도 돼요. 질문을.
교수님, 저 출석 관련해서 혹시 질문이 있는데.
출석
네.
관련해서 질문은 나중에 하세요.
네,
네.
알겠습니다.
네. 또. 네, 그러면 네, 일단 녹음을 끝내고, 예, 여러분 수고 많으셨고요.